Welcome to the So That's Why podcast, where we unpack the science behind everyday questions. I'm Jen.
I'm Chris.
And I'm Jamie.
Okay, so hands up if you've ever pulled out a single strand of hair, held it up to the light and thought, when did that happen? Why does our hair turn grey? Because it's one of the most visible changes our bodies go through, and yet most of us have no idea what's actually going on beneath the surface.
It really is. And can we talk about the universal panic of finding your first grey hair? You spot one in the mirror and suddenly you're doing a full scalp inspection like you're searching for contraband. Then you're texting your mates, asking when theirs started, trying to work out if you're ahead of schedule or behind schedule.
I remember my first grey hair. I was convinced it was just a trick of the light. And so I actually moved to about 3 different mirrors before I accepted that it was well and truly white.
And here's something that might surprise you, that your hair doesn't actually turn grey, it grows grey. So every single strand of hair starts off completely white before pigment gets added. So when we say our hair turns grey, what we actually mean is the pigment system has stopped doing its job.
So it's such a good distinction that, because so the colour we see is essentially being painted on during the growth process.
Exactly right. So we have specialised cells called melanocytes, and they sit inside each hair follicle and they inject pigment into the hair as it grows. And there are 2 types of pigment. We've got eumelanin, which gives you the black and brown shades, and pheomelanin, which is responsible for blonde and red tones. Your unique combination of those 2 determines your natural hair colour.
Hold on, that's actually kind of amazing. Thousands of tiny cells are just deciding what colour our hair should be.
Exactly 100,000 of them, to be exact, on the average head.
I wonder who actually counted them. Each of them goes through repeated growth cycles as well. Melanin, it's regenerated at the start of each new cycle, but after roughly 7 to 15 of those cycles, the production starts slowing down, doesn't it? So there's almost a built-in limit to the colouring.
15 cycles sounds like a lot, though. How long is each cycle?
So it's anywhere between 2 to 7 years, depending on the person. So the maths is different for everyone, but eventually the pigment production starts winding down.
Now, here's where recent research has changed our understanding significantly. So there was a study published in Nature that revealed something incredible about the stem cells responsible for hair colour. Why don't you tell us more, Chris?
Yeah, so this really was an important piece of research. And what it told us was that melanocyte stem cells, which are the parent cells that produce your pigment-making melanocytes, are uniquely mobile. They normally shuttle back and forth between different compartments within the hair follicle. In one follicle compartment called the bulge, they sit dormant. In another, called the hair germ, they receive chemical signals from proteins that tell them to mature and start producing pigment.
And the key finding was that as hair ages and the cycles repeatedly, these stem cells start getting physically stuck in the dormant compartment. So they stop migrating to where the make pigment signals are. So they never get the instruction to actually produce the colour.
So it's not that the cells actually die, they're just stuck in the wrong place. That's like having all the ingredients for dinner sitting in the cupboard, but nobody's walked into the kitchen to actually start cooking.
Yeah, that's a fair way to look at it, actually. And it's been described as those stem cells losing their chameleon-like function. And this is actually encouraging, though, because stuck cells are potentially fixable. Dead cells aren't, of course.
But there's a second mechanism at work too, isn't there? And this one involves something you'd normally associate with bleach in your hair, and that's hydrogen peroxide.
Absolutely right. And your hair follicles contain and produce small amounts of this hydrogen peroxide naturally as a byproduct of normal cell activity. So under healthy conditions, an enzyme called catalase breaks it down into harmless water and oxygen. But as we age, catalase levels decline, so that hydrogen peroxide builds up and starts interfering with the pigment production process.
And researchers at the University of Bradford, they confirmed this when they analysed pigmented hair versus grey hair. So the grey and white hair samples contained high levels of hydrogen peroxide, whereas the pigmented hair had none. So effectively, your hair is being bleached from the inside.
So your own body is giving you highlights without your permission. That explains why grey hair often has a slightly different texture too. It's been chemically altered at its source.
It does, and the hydrogen peroxide doesn't just block pigment production, it also damages the repair mechanisms that would normally fix the problem. So it's created a compounding effect over time.
Now, one of the most interesting areas of research has been around stress and greying. So we've all heard that phrase, or you're giving me grey hair, or you're going to turn my hair grey. But there's actually science behind it, isn't there?
There is, and it's a fascinating piece of work here. So in 2020, researchers at Harvard published a study that provided the first definitive mechanism linking psychological stress to grey hair.
So stress generally does make your hair go grey faster?
Yep, it does. And what the Harvard team found was that under acute stress, the sympathetic nervous system, that's your fight or flight system, releases a burst of norepinephrine directly into the hair follicle. And this causes the dormant melanocyte stem cells to activate prematurely, rapidly use themselves up, and then they're gone permanently.
And genetics play a huge role too, don't they, of course, in how quickly you go grey. There was a study of over 6,000 people with diverse Latin American ancestry, and they identified a gene called the IRF4 as the first gene specifically associated with hair greying. So that gene is estimated to account for about 30% of greying, with the remaining 70% down to age, stress, environment.
So nearly a third of your grey hair timeline is written in your DNA before you were even born. That's reassuring or deeply annoying, depending on your family photos.
Yeah, there's nothing quite like a family album to give you a preview of the coming attractions.
Yeah, there are ethnic patterns too. So people of European descent tend to start greying in their mid-30s. Those of Asian descent in their late 30s, and people of African descent a bit later, so typically in their mid-40s.
And then there's premature greying, and that varies as well, doesn't it? So before 20 for Caucasians, before 25 for Asians, and before 30 for people of African descent.
Right, so going grey at 28 might be premature in one group and completely normal in another. It's another example of why universal health benchmarks don't always work.
Yeah, definitely. And for premature greying specifically, nutritional deficiencies are a factor that's often overlooked. So vitamin B12 is particularly important because that supports melanocyte function, and deficiency is one of the most common nutritional causes of early greying. So studies have found significantly lower B12 levels in people experiencing premature greying.
I wonder how many people are now adding B12 to their shopping basket. Copper's another one, isn't it? It's a cofactor for tyrosinase, and that's the key enzyme in melanin production. So if you've got low copper levels, that's been directly linked with premature greying. Iron and zinc and even vitamin D and calcium have also been flagged for research too.
So if you're going grey earlier than expected, it might be worth checking your nutrient levels rather than just blaming your grandparents.
Yeah, that's right. And in some cases, addressing a deficiency through diet or supplementation may help slow further greying. It's worth noting that reversing existing grey hair through nutrition alone is uncommon. The biggest benefit is in preventing further progression.
But the practical side of this, it's actually quite encouraging though, isn't it? Because while we can't change our genetics, we can absolutely influence the nutritional and lifestyle choices that we make. So making sure we're getting enough B12, maintaining good iron and copper levels, managing stress, getting enough sleep. I mean, these are all things within our control that affect the biology we've been chatting about.
Yeah, so basically eat well, sleep well, stress less, and your hair might thank you for it. Simple. Said no one living in the real world ever. But knowing the reasons behind it does make you take it a bit more seriously.
Yeah, and there are some other factors that can accelerate things. So smoking's been associated with premature greying. Thyroid disorders can disrupt the melanocyte function. And there's also some autoimmune conditions that attack the melanocytes directly.
So what about reversing grey hair? Is it actually possible, or are we firmly in the wishful thinking territory?
So it's not as far-fetched as it once sounded. The NYU finding that Jen mentioned earlier, that stem cells get stuck rather than die, is significant because it suggests that if we could persuade those cells to start moving again, pigment production could theoretically restart.
There have been documented cases of individual grey hairs naturally redarkening too, which shows that the process, it isn't always a one-way street. There was a small study in 2025 and they explored rose stem cell derived exosomes as a treatment, and 100% of those patients achieved significant improvement, but the research is still in its very early stages. So Watch this space.
So we're not there yet, but the door is open. That's more hopeful than you would have thought.
Yeah. And some medications used in cancer treatment, they've also been observed to trigger hair repigmentation as a side effect, which has given researchers additional clues about which biological pathways are involved.
Yeah, that's right. And the closer someone is to the early stage of greying, before that stem cell pool is fully depleted, the better the chances of any future treatment working. So there is a reason to be optimistic.
Indeed there is. So to answer our question, why does our hair turn grey?
So hair turns grey because the melanocyte stem cells responsible for producing pigment gradually lose their ability to function. They can become physically stuck in the wrong parts of the follicle. Hydrogen peroxide buildup and disrupt pigment making machinery. Stress can deplete the stem cell reservoir through the fight or flight response, and genetics set the overall pace of this greying process.
So your grey hairs aren't a sign of failure. They're a sign that roughly 100,000 tiny pigment operations have been running successfully for decades, and some of them are finally coming to an end.
So that's why your hair turns grey. It's a combination of stem cell biology, oxidative chemistry, your nervous system, your genes, and even your nutritional status all working together. And the exciting part is that researchers are closer than ever to understanding whether some of it might be reversible. That's it for this week. Make sure you hit that subscribe button. We're unpacking the science behind everyday questions each week. Tell us in the comments what you'd like us to explore. Thanks for geeking out with us. But for now, that's it from me.
That's it from me.
And that's it from me.
Bye for now.